Welcome to our HP Tuners live training session part 4 with our Pontiac Firebird. In this video, we're going to learn how to tune our speed density volumetric efficiency style strategy, going through the calibration process for idle, for part throttle cruise, and for wide open throttle. We're also going to take a look at setting up our dynamic blend point so that we can then work with our speed density and the mass airflow together the way that GM has designed the ECU to work. We're going to have a lot to cover, so let's jump into our live training session so we can get started. Welcome back to our live training session here with our Pontiac Firebird. In the last video, we mapped out our mass airflow curve. We went in and tuned some spark timing. We made about 480, 490 horsepower with this motor. So it was relatively easy to tune. There was a lot of setup. We set up our idle control. We did our throttle relearn. We have everything sorted out. The idle control's working nicely. We have all of our injector data sorted out. Everything seemed to be okay with what we programmed. We didn't have to go into our latency table to deal with things or a short pulse width table to deal with things. Everything seems pretty accurate at this point. So we're now going to go and convert our file over to speed density. So we're going to use our volumetric efficiency table. We're going to be ignoring the mass airflow sensor, and then we're going to be calibrating the VE table so that it registers the exact same amount of airflow that we found with our mass airflow sensor. We should find that the dynamic airflow, which is going to be looking at either the MAF or the speed density calculations, should be almost within a pound or a half pound per minute of airflow. So we should see, if we go back into our scanner here, this very last pull, we were registering right around, we're taking a look here, about 45 pound per minute peak. We should see when we're running in speed density mode that we're registering that same amount of airflow. With the mass airflow sensor, we're measuring the airflow and we're calibrating everything. When we're in our speed density mode, we're inferring or we're going in and calculating the amount of airflow. So it's going to be a difference of how we're going to go about doing it. So our job now is to go into our VE table and do the calibration process. If we jump here into engine, jump into airflow, into main VE, into the primary table, we're going to be working with this table. Now in our second video, we built our histograms so we could do an overlay for our closed loop trims on top of this table. And we went in and we also did the EQ ratio error. So looking at the difference between what we're commanding in our power enrichment and what our wideband's reading, so we can tune both closed loop, part throttle idle situations and wide open throttle, and we can sort this table out relatively quick. We should find that if everything's calibrated right and it's registering the exact same amount of pound per minute airflow from the table, it's calculating that and not measuring it, we should find that the spark time is going to fall in line right where it was with the mass airflow sensor. We should find that the fuel delivery is all going to be consistent and accurate. And then when we put it into the dynamic mode where it's going to be blending between the mass airflow and the speed density, it's going to have seamless integration. We're not going to have it doing anything quirky or weird. It can run between either. Now, if you're going to be running just speed density, this video would be applying to you. When I'm in a situation like this with a vehicle that's making reasonable power, it's naturally aspirated, I don't have to worry about exceeding the mass airflow sensor. I'm going to stay using the mass airflow sensor. It just keeps things more consistent. Going speed density is definitely desirable when you have a car that's going to make a bunch of power. We don't necessarily want to run an 800 horsepower car in a mass airflow, though we could. But on a Gen 3, we can just switch it to speed density. It works very, very well, and everything's going to be sorted out. But we want to find, if we're doing this hybrid blend mode, that we have our mass airflow registration coming in from our dynamic airflow, matching what we found here, around 43, 45 pound per minute worth of airflow. So in speed density mode, that's what we're looking for to validate what we did and what we've tuned and how we've set everything up. Now, when I went in and I calibrated everything on the mass airflow sensor, we know that the injector data was relevant. We don't have to go in now with speed density operation and tweak our flow rate table or any of our injector data. If things are off in our mass airflow or the VE table here, so if things are showing us deviations here of having to go and increase the represented airflow from this table, then we're going to do that. We're not going to jump into our injector data and tweak things because we validated everything works when we're in mass airflow mode, which is nice. If you have both MAF and MAP, you can go between both of them and do a checksum. You can check it on MAF, check it on MAP. Everything should line up pretty well, and you know that things are sorted out and you have your calibration process tuned properly. So again, we're going to fire it up. We're going to do our calibration change quick. We're going to fire it up in speed density mode and start to calibrate this table. I do want to mention these values in this table represent the cylinder filling of the engine. If we're saying that the value is higher, if we have more cylinder filling, it's going to then calculate what that airflow or air mass is going to be that it's theoretically thinking is coming into the engine. It's going to then know the air mass divided by the target air fuel. It'll calculate the fuel mass knowing our injector data and deliver that fuel to the engine. So this table, we need to treat it as a simulated mass airflow. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.